Hey math fans, welcome back to chapter 3 section 6. This is part 2. In this video I'm going to do distance between two parallel lines. So the first video I was giving you a point off of the line and you calculated the distance between the two. Here I'm going to give you two parallel lines and you need to calculate the distance between the two. So I have a vocabulary word to cover with you now, and that is equidistant. So it says that two lines in a plane are parallel if they are equidistant everywhere. So if I draw a line here and a line there, and then I calculate the distance between various line segments, and they're all the same, then you can conclude that the lines are parallel. So equidistant essentially just means equal distance, right? But it's officially defined as the distance between two lines measured along a perpendicular line to the lines is always the same. And then it says right here, the distance between two parallel lines is the perpendicular distance between one of the lines and any point on the other line. Okay, great. So what does that mean to you in the math sense? Well, you're going to have two equations, and they're going to be parallel lines. So they have the same slope, so 2 and 2. And so we're going to create an equation that runs perpendicular to these two lines and then calculate the distance between those lines. So right here in step 1, I say write an equation of a line perpendicular to L and M. And so this is like a sub-step. And I say pick the y-intercept out from line M or line L. It doesn't matter which y-intercept you use, but I'm going to use line M to use as your endpoint or / y-intercept of your perpendicular line. And we're going to call it line P. So basically what I'm saying here is use the y-intercept of line M. Here's line M, y equals 2x minus 3. So my y-intercept here is at 0, negative 3. How do I know that? Because remember, this is in slope-intercept form. The 2 is the slope because it's married to the x. It's the M. And then the minus 3 is the b, the y-intercept, where it begins. So I'm going to use 0, negative 3 for my endpoint there. And that's going to be similar to what we did in part 1, where I gave you a point off of the line. Well, so where I'm going to use this as that point, okay? So there's my y-intercept. Now I need to know what my perpendicular slope is. Well, if my slope for my other two lines was 2 over 1, or just 2, but 2 over 1, then my perpendicular slope is going to be negative 1 over 2. And so my line that runs perpendicular to those is now just going to say y equals negative 1 over 2x minus 3. So this is already a considerably less amount of work when compared to the last video. That being said, we have some more work ahead. So that's step 1, creating the perpendicular equation. So step 2 is to graph lines L and P. You can graph line M if you want as well, but you need it to intersect with line P. So I'll show you what I mean on the graph. Okay, so here I've graphed lines L, M, and P. And so if you just graph lines M and P, the instructions say graph lines L and P. And so if you graph just M and P, they would just be intersecting here at 0, negative 3, which we've already used. We already used that point. So it doesn't matter if you graph all 3 lines or just 2 of them. Because they intersect here at 0, negative 3, as they should. That was the point I used here for the y-intercept. And so they intersect again. Well, lines P and M, L and P intersect at negative 1.6, negative 2.2. So like in the previous video, I'm going to call that point Q. So I'll say Q is at negative 1.6, negative 2.2. So what I'm going to do now is calculate the distance between these 2 points. I use 0, negative 3 as my end point, so to speak, that point off the line, the point off of this blue line L, if I'm going to relate it back to part 1's video. But yeah, basically plug these into your distance formula. It doesn't matter which one is x1, y1, which one's x2, y2, but I guess since this is my first point, I'll use this as x1, y1, and since I figured that out second, I'll use this as x2, y2, but it really doesn't matter. So my distance formula is x2 minus x1 squared minus y2 minus y1 squared. Add those two values together and then take the square root of it all. So I'm going to type into my graphing calculator or scientific calculator, whatever, negative 1.6 minus 0 squared plus negative 2.2 minus negative 3 squared. And so that's going to give me negative 1.78888543. So I often ask you to round to the nearest thousandths place, which would be round to the nearest 3 decimal places. So here's the 3rd decimal place, it's an 8. Look at the 4th decimal place, that's another 8. So that 8's going to round this 8 up to a 9. So I'm going to say my answer is about 1.789. And that right there is the final answer to that question. Okay? So I'm going to do another example, just different equations, but same process. So example 2, find the distance between the parallel lines L and M with the equations y equals negative 1/2 x plus 4 and y equals negative 1/2 x minus 6, respectively. So the first thing I did on the other one was I picked out a y-intercept. So it doesn't matter if you use the first y-intercept or the second one. I'll just use the second one because that's what I did last time. So I used a y-intercept, and then that'll be at 0, negative 6. How did I know that? Because there was a minus 6 right there. If I had chosen to use the y-intercept of this, I would have written 0, positive 4. So anyway, I use 0, negative 6. And then I need to know my perpendicular slope, right? Well, what's perpendicular to negative 1 over 2? That'll be opposite reciprocal, so positive 2 over 1. So, or just 2, okay? So my y equals mx plus b, my perpendicular line is going to say 2x minus 6, okay? So there's my perpendicular line. And then what I'm going to do now is I'm going to graph these 3 lines, and I'm going to get the intersection that's not happening at 0, negative 6. Oh, and like the previous example, I'll call this new line line P. So here I've graphed all 3 lines again, and I've color-coded them. Black is L, red is M, and blue is P. So this would be the intersection between lines M and P, right? They would intersect at the y-intercept because I used the y-intercept from M to create line P. So anyway, this is the intersection I'm after. This is point Q right here. So like in the previous example, I'm going to calculate the distance between these two points. So it doesn't matter which one you say is x1, y1, x2, y2. So I went ahead and just labeled this as x1, y1, and this one as x2, y2. And we're going to use our distance formula now. So we're going to say the square root of, so I have x2 of 4 minus x1 of 0 squared plus, then I have y2 of 2 minus y1 of negative 6. And then all of that's going to be typed in under the radical. And so I'll get 8.9442719 and other stuff after that. So I'm going to round this to the nearest thousandths place. So I'm going to look at the 3rd and 4th decimal place. So does this 2 round up that 4? No, it does not. So I'm going to say for my final answer is going to be 8.944 units. Okay? So that's going to wrap it up for this video. Thank you for watching, and goodbye.